I'm too lazy to get on the camera, but you don't even care seeing me, you selfish little bastard. You just want to see what I have for you. Well, I'm not gonna tell you, okay? So you're gonna trust me and we're going to create a really cool game over here. So we're going to start over here inside the blueprints, and I'm going to right click, and by the way, you can download this starter project in my or on my website awesomedudes.com, so go there and download it. So we are going to start over here by creating a user interface, and this is going to be our widget, and I'm going to call this one BP game underscore UI because it's going to be the UI for the game. And what I'm going to do here is first drag the tab, there you go, and let me drag here a text which is going to tell us how we are going to play the game. So this text that I'm going to click over here, and I'm going to call message text like that. I'm going to make it a variable, so is variable over here is going to be checked, as you can see. And let me just open my zoom tool, which is this one that you see on the screen, that allows me to draw because I'm an artist, okay? And what I'm going to do is set the anchor at the top middle, and now set the position X to 9 or negative 950, 12 for the Y, and the size X can be 544 and the size Y 64. There you go. I'm going to type over here for the content, not the text block, but I'm going to say here, press in quotes E to throw. Automatically you can assume it's something that we are throwing in the game because this game is about throwing stuff. You know, like you get, I don't know, your girlfriend throws you out, so that, there you go. So over here, I'm going to set the font to 36, but I'm also going to set the alignment in the middle. And I'm going to change the color, clicking here on the opacity, or actually on the color, and set here the hex 095000FF, but it's not important. You know, it will not change the game, it will not change how we play the game, it will basically not do anything. So I'm going to copy this text, and now I'm not going to call it message text, but I'm going to call it score text. There you go. This one also needs to be a variable, and the anchor will be at the top middle. And I'm going to set here the position X to minus 200 and the position Y is 32. The size X is going to be 400 and size Y is going to be 100. And over here, I'm simply going to say score colon and let's say 0 because we are not better than you know, that score, okay? So moving over here in the size, I'm going to say 52 and the color is going to be bluish. So click OK and there you go. Don't worry about the red lines or the green lines around the score. That's not important. The important thing is that the score has a color of blue. Let me just compile and save that. So compile first and save. Select the score here in the hierarchy, Control C, Control V to copy and paste it, and this one is going to be best score. But for the best score, I'm going to set the anchor at the top left and set the position to minus 400 for the X, and the Y is going to be 32 and 400, 100, size X, size Y. That is totally fine. Over here instead of score, I'm going to say best, and voila, there you go. The font and everything is going to stay the same like we changed the font so far, but I'm going to change the color to, let's say, CA2400FF. But again, it's not important. It will not, you know, change basically how we play the game or something like that. So let's go over here in the graph. Make sure that you have these variables, best score, message text, and score, and I'm going to remove all of this. There you go. And I'm going to go here inside of the functions and click on the plus, not the functions here, override, but plus over here. And this one is going to be called update text. Or actually, no, what I'm going to do is I'm going to close that one and I'm going to create, first delete this one, but I'm going to create a custom event. So custom event, there you go. And this one is going to be my update text. I don't want to create a function for that. And what I'm going to do here is select it, and it's going to take 2 parameters. So when you click on it over here in the inputs, click on plus, and one is going to be score type of integer, and click on another plus, and this one is going to be called best, like the ice cream best. I don't know if you have that in your country, but yeah, that's an ice cream. Anyways, let's go over here and take the score text, and from here I'm going to say set text like that. There you go. And this one is going to be plugged in over here like that. Now for the text, what I'm going to do is take the score and I'm going to say to string, or actually to text, because this is an integer, so to text. I'm going to expand this, by the way. And over here, the minimum internal digits 1, the maximum is going to be 2. I'm going to uncheck this use grouping because we're not going to group it. And what I'm going to do is right click and say format text, like that, and move these nodes a little bit from here. And for the format text, I am going to add, I think I need to click right here. Do I need to click for another pin? So let's go here, not promote to variable. For whatever reason, it does not allow me to, come on, not promote. How can I add another pin over here? It's not allowing me to click refresh, break, collapse. Let me see this over here. I'm going to say score and colon, and over here I'm going to say value, like that. And there you go. Finally, that does give me over here. And the value is going to be this one. Voila, like that. And I'm going to plug this in over here. There you go. Compile and save. So what is happening over here? Well, when I say score and over here in these curly brackets, this value is going to be this dude over here. As you can see, this will add a new pin. I thought that I need to right click, but apparently I don't, okay? So anyways, over here, there you go, score colon, and then we have a value that we pass, which is basically this integer that we have converted. Now, moving forward, we're going to do the exact same thing. So I'm going to copy this and paste it, but this time I'm not going to say score text. Instead, I'm going to say best score, and this one is going to be plugged in here. And from here, I'm going to say best and not score and then value, but I'm going to say best, and this one is going to be plugged in here, like that. I do need to copy this and paste it. So voila, actually this goes over here. I need to delete this node, and this one is going to be plugged in here. And for the value, it's this one over here, the best one. So let's go and add some extra, how are these called? I don't know, but you get the point. These, simply double click on, double click like this over here, and there you go. So I need to connect these because I deleted that one. Voila. And compile and save that. This is only going to preview the score to our user. So nothing complicated, nothing, out of the ordinary discovery or whatnot. So there you go. Now, moving forward, let's go here in our minimap. I'm going to right click and create a blueprint class which inherits from the actor, and I'm going to call on this be BP dice. This I'm going to call it. Double click it and open it. And for the dice, we need a static mesh. So static mesh, here it is. I'm going to call this one dice mesh, and we need to, this is really important, we need to make it the root component. So drag it on the default scene root to make it a root component, because if we don't do that, this is not going to work. So make sure that you do that. Over here for the mesh, I'm going to click on the drop down list and select the dice, and this is our dice. You can automatically now see what game we are going to create. And over here I'm going to check the simulate physics. Mass is in kilograms, not 100 but 50, because this is a, let's say a little bit fat cube. Over here, linear dumping is going to be 0.1 and angular dumping is going to be 1. Linear dumping, the drag force added to reduce the linear movement is 0.1, and angular dumping drag force added to reduce angular movement is 1. That is it. I am also going to create a physics material. Now, what is a physics material? So let's go and see that. So inside of, let's say, in blueprints, I'm going to do it in blueprints. We need to go under physics and physics material, and it inherits from the physics material. And I'm going to call this one PM for the physics material. I'm going to call it bounce or bouncy, however you want to call it. Let's double click it. So the friction is going to be 0.5, and over here the restitution is also going to be 0.5. What the hell is that? If I hover over friction value of the surface, you see it controls how easily things can slide on the surface. 0 is frictionless. Basically, if you want to create a game like a slide game, then you would use a material with zero friction. 1, so the higher the value increases, the higher value increases the amount of the friction. The restitution is bounciness. So for whatever reason, they changed the name to restitution instead of bounciness, which is much easier to understand. But there you go, I have translated the restitution. So this is the bounciness amount. Let's go back in the dice, and over here for the physics, I believe, actually no, here in the collision, select the PM bounce. And this would be it when it comes to what we need to create or to set up the dice. Now let's go here inside of our event graph and delete this, because we are first going to create our variables for the dice. Over here for the variables, click on the plus button, and I'm going to say face normals like that. And next we are going to have over here up face like that, and last but not least, launch impulse. So impulse, there you go. Launch impulse is going to be a float. There you go. The default value is going to be 500, but we still don't have it. Let me just save that. And now the default value, I'm going to set that to 500 for the launch impulse. The up face is going to be an integer, which is going to represent the facing of the dice. So does the one face or two or I don't know, 3, 4, whatever. And over here, the face normals is going to be a vector, but an array. So right click over here on this little icon, and it will make it an array. And for the face normals, we are going to have 6 elements. So 1, 2, 3, 4, 5, 6. There you go. So the first one is going to be Z1. There you go. X and Y are 0. The next one is going to be -1 on the X, 0, 0. Over here. For the 2 over here, we're going to set 1 on the Y and 0 for the Z and the X. Over here is going to be -1 for the Y, 0 for the X, 0 for the Z, 1 here for the X, 0, 0, and over here -1 for the Z axis. Basically what this is going to represent, if it will depend which face is the dice on. Because over here, if I go and select the dice and actually go here, so this is the scale. Let me just see that. Do we have here? Yeah, we don't. It doesn't show here the position. It shows only the scale. But basically, when the position over here, the Z at 1, that means upwards. So it means upwards. The Z over here, -1, it means down. So whatever position or whatever dice is here, you see Z -1 means 6. If I go up over here, Z1 means 1. For the X, -1, it's this one over here, so 2. And over here for the Y, 1 means this one over here, which is 4. And -1, it means this one, which is 3. There you go. So this is what we're doing. X1 means this one over here, which is 5. So these are basically the values that we have or represent with these over here face normals, so to say. Now, going back or going inside of the event graph, I'm going to move this one over here. I am going to right click and create a custom event that I'm going to call throw. And for the throw, I am going to take the dice mesh and I'm going to say here, add impulse, so impulse at location. And this one is going to go over here. So it's going to add impulse on the dice static mesh at the location. First things first, I'm going to calculate the impulse value. So I'm going to take the dice mesh and I'm going to take the mass from it. And now when I get the mass, I'm going to also take the launch impulse, which has a value of 500, and I'm going to multiply these two. So multiplied with float, this goes here, there you go. And next I'm going to take a vector, a multiplied vector, multiplied with float. And this one is going to go here, and the value for the vector is going to be 1 on the Z, and I'm going to plug that in. Why 1 on the Z? Because the Z means upwards, so it's going to propel it upwards, and that is why I'm using Z over here for or setting 1 on the Z. For the location, what I'm going to do is I'm going to right click, get actor transform, first things first, like that. And I'm going to go from here and say transform location. like that. And which location do I want to transform? Well, first I'm going to say get actor bounds. And over here, only colliding components. And this is basically, if I hover over, come on, is it going to display it? Returns the bounding box of all components that make up this actor. Basically, we're going to have over here inside of our game a trigger box, which is this one. Here it is, which is down here. It's already set up for you if you downloaded the project. And what this is going to do, it is going to get the location of the actor within that box, basically. So over here, I'm going to say random point in bounding box. And I'm going to box extend origin, there you go. And this is what I'm going to plug into this transform location. Now the transform location, you see, transforms a position by the supplied transform. For example, if T, which is the transform over here, which is the transform of the dice, was an object transform, this would transform position from local space to world space. So this is what we are doing, and then I'm going to plug that bad boy over here inside of this location, compile, and save that. Now, before we move on, there is also one more thing that we need to do, which is using the tick event. And from the tick event, we are going to go and create a custom event first that I'm going to call break for each loop. And from here, we're going to enter the for each loop with break, like that. And this one is going to break the loop when we call it. And the array that we are going to loop through is going to be our face normals, which we explained what that means because every value inside of this array represents the facing of the cube. So from here, we're going to set the up or face up, set face up, here it is, or up face, excuse me. We're going to change that value to 0, and then we're going to enter a branch. And the condition for this branch is going to be, and I'm going to take all of this, move it a little bit upward so that this right here does not obscure us. The condition for this branch is going to be, I'm going to right click and say get actor transform. And we are again going to transform direction so that we know which direction the cube is facing, and the direction is going to be the current element in the array, or basically the current value from the array. So this is what we are transforming, and then from here we're going to get the dot product in comparison to the z, which I'm going to set that going to be equal to 1 because we are comparing it with the facing upwards. So the dot product between the current direction and facing upwards to know, because I said 1 means facing upwards. So z1 facing upwards, z minus 1 downwards, okay? Y1 facing forward, y minus facing backwards, x to the left, so minus 1, x to the right, there you go. So this one is facing upwards. I'm also going to go here and check if it's greater than float and pass over here 0.6 and plug this inside of the branch. So what are we testing with the dot product? What does dot product even do? Well, basically over here, since we are comparing it with another float, this means if the dot product is greater than 0, then this direction is facing the same direction as this one that we passed in the dot product, which is 0, 0, 1 for the z, which means upwards. So if it's greater than 0, in our case, if it's greater than 0.6, these directions, so this direction and this one over here, so this one and this one, they both are facing the same direction, which means upwards, and then we will know that, or which side the dice is facing. Now, after that, what we need to do is we need to say set up face, and we need to add to it. So we need to say over here, integer plus integer, like that. And for this integer here, we are going to take the index of the array, plug it in, but I'm also going to do this so that we can see more clearly. This goes here, there you go. So taking the index of the current element, plugging it in over here, adding 1 to it, and then setting this face up value to be equal to that, new value. And after that, we're simply going to call here break for each loop, which is the custom event that we have over here that we have created, which is going to break out of the for each loop. Now, before we proceed to code everything that we need, I'm going to go here in the map and I am going to drag the dice, and here you go. And this one is going to be, I'm going to click on it and call it dice 1 and set the scale of this dice to 1.5 for all 3 axes. And then I'm going to set over here the location to 20x, 30 on the Y, Z is going to be 180, and the rotation is going to be minus 122 on the X, 22 on the Y, and minus 23 on the Z. There you go. And next I am simply going to hold control or command, control I believe it's on, because I have a Mac keyboard on Windows, how ironic. But anyways, over here, let me set that to minus 90 on the X, 30 and 180 on these can do. Over here, 160 rotation, minus 44 over here, actually 45. And last but not least, 127 like that. And this is what we want in terms of where we want to place the dices. I backed out there, I blocked out. So what do we need to do now? Next, I'm going to save all of this and go here under blueprints and click on this drop down list and then go here open level blueprint, which is going to open the main map blueprint. For the variables on the side, we are going to have our game UI, which is going to be a type of our game UI, and we are going to have over here grounded, so grounded dices count, and the best score as well. So best score, there you go. The best score and the grounded dices are going to be type of integer, and the game UI is going to be BP game UI, which is going to be an object reference. Now over here in the begin play, so begin play, we are first going to create the widget. So I'm going to say over here create widget like that. And it takes an owning player, which is going to be get player controller. We need to pass this over here. There you go. And from here, it's going to create the BP game UI that we have, created first. And we're going to set or get a reference to it. So setting that value over here. After that, I'm simply going to add it to the viewport. So add to viewport. Voila. There you go. Whoopala. And now we're finished. Thank you for watching. I will see you guys in the next video. Just kidding. Moving forward. I'm so funny. Moving forward, we need to get a reference to the dices. So what I'm going to do is move this over here. And this one goes over here. So let me just resize it. I don't know how to do this another way. And probably there will be wise guys over here that are going to tell me, oh, you should have done it like this. I do not care. I'm going to do it like that. Okay, I like doing it like this. While I am at it, I'm going to select this trigger box and I'm going to right click here while I have it selected here, and I'm going to say add event for trigger box, and we are going to add collision on actor begin overlap, and over here I'm also going to add collision on actor end overlap. This is both for this trigger box. So there you go, compile and save that. So voila, this goes here, we will cover that. But first, what I'm going to do is I am going to get the key code. So over here, input E, and not mouse, not touch, not ear. Okay, not this one, not this one, not this one. Come on, can I get the keyboard events? Here it is. And we want when we press the E key. So what's going to happen when we press the E key? We're going to compare an integer, and the integer that we are going to compare is going to be the grounded dice, which is going to count how many dices we have on the ground, and this is going to go here, and we're going to compare it with 2, because we need 2 dices to be on the ground for this to work. So now over here I'm going to say make array, And this one is going to be plugged in here. This one's going to be plugged in actually over here. Right click. Oh, here it is. Add one pin. This one goes here. This one goes here. And then we're going to go from the equal sign because we're comparing the grounded dices to 2. If it's equal to 2, that means we can perform or throw the dices in the air. So from here, I'm going to say for each, so for each loop, there you go. And the array is going to be plugged in over here. And then we're going to take the element or the current element in the array, and from it we're going to call the throw functionality that we have created inside of the dice, which is this one over here, this bad boy over here, which is going to have or add an impulse at the location with the impulse that we already created. But only if we have 2 dices on the ground. How can we know if we have 2 dices on the ground? Well, for that, we're going to use these on begin overlap. And what I'm going to do is test over here, cast to BP dice. So if the dice is colliding with that trigger, then I am going to set here, set grounded. So set grounded dices count. And from here, I'm going to take the grounded dice count and I'm going to say plus integer like that, and plug it in over here. Similarly, I'm going to copy this, paste it over here. And again, if we collide with the trigger after we end the overlap, I'm going to do the same thing, except over here, I'm going to say minus integer, which is going to subtract 1 from the dices or grounded dices count. Compile and save that. And there you go. The last thing that we need to do is we need to set the score. In order to set the score, we need the tick event. So tick from here, and we are going to compare our grounded dices count. So from here, compare int. So compare int. And this is going to be plugged in over here. And we're going to compare it with the number 2 because we need 2 dices on the ground, okay? And what I'm going to do here is from the equals, I'm going to set the best score. And the best score is going to be calculated, taking the best score, and over here max, comparing max, and we will see how this is going to be compared, because over here I'm going to take the dices again. So these 2, copy them, paste them here. And from the dices, I'm going to get the up or face up, however you want to call it, from here, up face, there you go, like that. And I'm going to, how's it called? Add one to another, not subtract, but whatever, you get the point. I'm going to say up face from the dice 1 plus the up face from dice 2. It's less complicated. And from here, I'm going to say select integer. And who are we going to select? Integer A or integer B? Well, for that, I'm going to take the grounded dice and I am going to compare that if it's equal to another integer, and the equal is going to be 2. So if the dices that are on the ground is equal to 2, I'm going to put that over here. If it's true, we are going to pick the A as the value. If it's not true, then we're going to pick 0 as the value. And from here, I'm going to plug that into the maximum that goes over there. And from here, we're going to take the game UI and we're going to call update text. Set that over here. Voila, there you go. And for the score, I'm going to plug this bad boy over here. So this one goes for the score, like that. For the best score, I'm going to take the best score and copy it, but we can also do it from here as well. It will work. So taking this, duplicating it, there you go, compile and save that. So what we did essentially over here is we are comparing these dices, or basically we're taking their face up from both dices, we are adding them, so we are calculating them, and then over here we'll have a select integer, you see, and based on the condition over here, if this is true, we are going to pick A, which is this one, and only if both dices are on the ground, we're going to pick A, otherwise we're going to pick B. And from here, the best score will be compared from this one over here that we have, which is the calculation of these two, and it will return the maximum between the two. and then plug that in over here and put that inside of the update text. We can compile and save that, and that would be pretty much it, I believe, you know, and it doesn't matter because you want to see the outcome, do you? I'm not going to show you. Okay, I'm just kidding. I'm going to go here, and when you see, first things first, look at that. So both dices landed on 3 and the score is 6. And also the score, or the best score, is 6. And why isn't it displaying the best score? Let me just go over here in the game UI. Let me see that. Okay, this is what, okay, break this from here. It needs to be best like that. Colon, and here value. And the value goes here, and then compile and save that. So now it is going to preview best. There you go. Now we have 5 and 6. That is now. So pressing E, look at that. It bounced them. Look, I am so good at this game. I have managed to beat it from the #1 try. But anyways, this is it, because now we have the best score, which is 12. 2 6s, that's all what we can do. And voila, there you go. Your assignment will be the following: add a third and the fourth dice and calculate the score. Also, what I want to do is, or what I want to challenge you, is to transform this into a C++ game. So everything is the same, but I just want you to transform this into a C++, and this will probably be in my academy. So if you want to see that, join the academy, link is down below. And if you're watching this in the academy and I have that assignment, make sure, I just gave you that assignment, make sure that you do it. I'm thinking about, will I do it or not? But anyways, maybe I will, for the people in the academy only. If you want to see that and you're on YouTube, go and join the academy. Anyways, that would be it. This is the project. You can download the finished project in the academy, because if you want it, I don't know what else to say, man. Just join the academy and I will see you there, and I will see you guys in the next video.